The room and portal system is meant to model the sound propagation from one room to another. So this blue cube over here has some music on it, has an emitter on it. And with this system, if the listener is in a separate room, so say this room, the sound should not sound like it's coming from the blue cube itself, but should sound instead like it's coming from this portal position. A portal is just the word I'm using for any doorway or window or opening that connects two rooms. And the system is based off of the system with the same name in Wwise Spatial Audio. So let's see how that sounds. So you can hear, although the blue cube is pretty much right in front of me, it sounds like it's coming from the left. Sounds like it's coming from the right, coming from this portal position here. I'm also taking the angle from the emitter to the portal to the player and using that to drive a low pass filter to sort of emulate the diffracted sounds will become filtered as you get a tighter angle. So let's look at how this is all set up. This is using these two actor blueprints. We have the portal and the room. Both of them are blueprints with some sort of collision on them, a mesh for the room, a collider or a box collision for the portal. So what a room should do is fill up the entire geometry of the actual room it's in. So here's like a bunch of different rooms. And then a portal should do something very similar. It should fill up the geometry of the opening it's in, but it should also be stretched across the Y extent. So it's overlapping both rooms. This helps a portal know which rooms it's connected to, which two rooms it's connected to, and also helps for cross-fading or like fading in the portal effect as you walk through a portal. So on the actual portal object itself, we have a public bus variable. So this is a just an audio bus manually set up. Every portal has an audio bus, and these audio buses will be the actual things outputting the sound. These audio buses will be sent to this portal source MetaSound, and these will be the actual spatialized sounds. So if we go into the portal blueprint here, we start off by setting that audio bus parameter in the MetaSound with the public variable that we manually set up earlier. Make sure that the rooms are loaded in. And then we're going to get the two overlapping spatial rooms and make sure that there's only two, or there's exactly two. And then grabbing the first room and assigning it as room A. We have these two spatial room variables, room A and room B, which these are the two rooms that a portal is connected to. We're assigning that to room A, and then we're going to make this portal data struct. This portal data struct is every room has an array of them. They contain all of the different portals that a room is connected to, and all of the connecting rooms that those portals are connected to. So a portal data struct will tell a room, one of my portals is this, and it connects to this room. So we're going to create portal struct B using the connecting room, room A. Then we're going to just do the same thing for the next room, make that room B, and assign it to portal struct A. Room B will be used for portal struct A. Then I'm just going to throw the different structs over to their respective rooms. So portal struct A goes to room A, portal struct B goes to room B. And that's pretty much it for the portal for now. So back now we can go over to the room. So when the room starts off, it binds this enter new room event dispatcher. What this enter new room event dispatcher is it will be called anytime the player enters a new room. So we can just look over in the player blueprint here. Right away, we're just checking which room are we overlapping and then calling enter new room. We're also calling this check emitter player room relation. This is sent to every spatial emitter scene component and does a similar thing. It tells the emitter that the player has entered a new room and you should check to see if you're in the same room as the player or not. This is just the on component begin overlap using the room listener. The room listener is just a tiny box collision I'm using to make it's small so that the player won't likely not be overlapping two rooms at once. So every time it does overlap a new room, we call both of these event dispatchers again. So back over to the spatial room. So right off the bat, this will be called on the event begin play in the first person character. But anytime this is called, we'll do the set portal bus source. So anytime the player moves into a new room, we will reset the player room to whatever room we got, and then seeing is this this room, checking it against that. If it is, then we don't have to worry about doing anything with portals. If it isn't, then we have to first look at its already active active portals array. It's an array of portals. Turn them all off, clear it, and then move into here. We're going to use the portal data array, which is that array of structs that we populated earlier from the portal blueprint. We're going to go through each of the portals, break it up, see if the connecting room is the same room the player is in. And if it is, then we know that's an active portal. We know this portal that this room is connected to also connects to the room the player is in. So we'll activate the portal. This is just an event that's on the portal I'll show later. And then we're going to add that to the active portals array on this room. So now let's look at how this is working for the spatial emitters. So we'll go into the room handling graph, which has all of the portal and spatial stuff. So we'll look at this set emitter spatialization. This is the event that is bound to that check emitter player room relation event, event dispatcher that's on the player. So this will happen anytime the player enters a new room. So if the player enters a new room, or if this gets called another way, we'll check if the emitter is within range. If it's not within range, if we're not hearing it, no point in doing all this stuff. We're going to make sure that the emitter room reference is valid. The player room is valid as well. We're going to make sure that there's at least one active portal. And then we're going to set the submix in. So this is just every room has a reverb submix on it. We're going to send the emitter to the submix of whatever room it's in. So if this is true, if either there is less than one active portal or the emitter's in the same room as the player, then we'll set emits from different room to false and set the portal amount to 0. The portal amount is just like a mixed dry knob for how much audio should be sent to the portal bus rather than the actual output. So 0 would mean 100% of the audio sent through the actual output. So in this for each loop, we're going to check all of the active portals. These active portals is just the array set earlier in the spatial room. For each active portal, we are going to set the array element in this portal buses array. This is just an array of buses. And we're going to use the bus on every active portal to set up that array. And then we're going to send all of those buses over to the MetaSound. So now the MetaSound will know all of the buses it needs to be sent to, one bus per portal. Then we're going to do this set spatial values for portal event. So let's our function. Let's get into this. So we're going to really quick check if we're in range again. The reason for this is that this is going to be on a timer later on. So if the player leaves the range of the emitter, we don't want to do all this stuff. So for each active portal, now we're going to set 3 values: the attenuation amount, which is because that we're sending all of our audio to a portal bus instead of outputting itself, that audio is not going to be attenuated at all. So we have to manually recreate it, which we'll do in this function. We're going to set the attenuation amount, the obstruction percentage. That's the obstruction from a from an emitter to a portal. Not worried about the emitter to the player obstruction, but just from the emitter to the portal. And then finally, the diffraction percentage. That's going to be the low pass that's driven by the angle from the emitter to the portal to the player. So let's hop into this function. This is done per portal. So we'll get the location of the portal, set that, get the obstruction percentage. This is the same function that we used earlier to get the direct obstruction, but we're just using a single line trace. We don't have to worry about just using a ton of line traces for that. And we'll use that to set the obstruction percentage. And then we're going to, we'll also be using that the target actor is going to be the portal itself. So we're setting the obstruction from the emitter to the portal. Then up here, we're going to set the portal attenuation. This function takes the portal location. Let's check it out. So this is the function, like I said earlier, that manually recreates the attenuation on a sound because it wouldn't happen since it's getting sent to the portal before it can be attenuated. So we're going to get the distance from the emitter to the portal, and then the distance from the portal to the player, add that together to get the total distance through the portal. So the total distance that the sound has to travel to get from the emitter to the listener, to the player. So we're going to do a switch on the attenuation distance modeling. This is that attenuation functions that we were looking at earlier. It's like linear, logarithmic, inverse. Depending on which one is selected, I just have manually how that would work out here. So then we will get the attenuation amount out after that. And then we're going to take a look at this. So there are circumstances in which you could have multiple portals that are active between 2 rooms. So that means there are 2 doorways that connect the same 2 rooms. If that happens, then the emitter will send its sound to 2 buses, but we want to compensate for the additional loudness that would happen from doubling those two that sound. We want the total decibels to be the same as it would be originally, just in the original sound, not any louder. So I'm going to take the length of the portal bus array. So how many active portal buses are we sending to? And then I'm going to throw that into the expression for figuring out how much dB is added for each additional portal. So if there are 3 portal buses, for example, this will, after this multiplication, it'll return the amount of dB needed to be taken away in order to get the same sound as the original sound. So I'm going to convert the dB to linear gain and then throw that out into the output, which is going to be our gain reduction. I'm going to multiply the gain reduction by the attenuation amount so that the gain reduction scales with the attenuation, and then subtract that out and send it out for the attenuation. So then for diffraction, like I said earlier, this is the angle from the emitter to the portal to the player. I'm going to get the direction vectors from the portal to the parent and then the portal to the player, and then get the dot product of those vectors and clamp that not from -1 to 1, but instead from 0 to 1. This will mean that a value of 1 will be not obstructed at all, or sorry, not no filtering at all. It'd be like a 0-degree angle, and a value of 0 would be like a 180-degree angle. And this is again linearly mapped against a low pass filter's cutoff frequency. So back into here, we take these 3 values and then set these different arrays at the index of the active portal that we're on in the for each loop, so that now these values will correspond index-wise to each active portal. After that's all completed, we're going to go over here and then pass all of these arrays over to the MetaSound. So attenuation amount, diffraction percentages, obstruction percentages. And then finally, we're going to execute this trigger parameter. This is the portal update trigger. This is just going to tell the portal to update all its values with these new arrays. So the last thing we're going to do in this set spatial values function is do this set portal amount macro. So the first thing we're going to check is, has the player entered a portal? How will we know that? Well, back in the overall graph, we have this fade portal event, which is bound to this enter portal event dispatcher. And that enter portal event dispatcher is defined over here as like just whenever the player collides with the portal, it'll be set to has entered portal. So there you go. Where are we going? Okay, so back into here, if the player hasn't entered a portal, and then if we're doing this at all, we know that the emitter is in a different room than the portal, then we're going to set the emitter portal amount to 1. It's fully sent to the portal. It's not outputting its own output at all. But if the player has entered a portal, then we want to start cross-fading these values. So we're going to get the Y scaled extent of the entered portal. Like I said earlier, I use the Y extent to, I widen the Y extent across the opening of the doorway to get this fade. I'm going to get the distance between the portal and the player, and then divide that by the total extent in order to get a percentage that the player has entered the portal, or the percentage that the player is in between the extent of the portal to the center of the portal. I subtract by 0.15 and then clamp this value from 0 to 1 and then set that to the portal amount. The reason I'm doing this subtraction by 0.15 is it just feels better. I thought it just felt more natural. Okay, so back out. So now we can take a look at the MetaSounds and how they are handling all of these values, all of these arrays. So we'll go back into the orb loop and see that we have this MetaSound patch, which is the emitter spatializer like we showed earlier. We have all of these arrays. We have the portal amount, the attenuation, the buses, diffraction, obstruction, and the portal update trigger. So in order to make a sound or a MetaSound use this room and portal system, this patch needs to be thrown in there, and then all of these need to be promoted to inputs. So let's go into here. So this is just a sort of a wet dry mix knob for if the portal is, or if a sound's being sent to a portal or not. If it's 1, then the entire gain will be 1 here, and this will be 0. So this is the portal bus output. So the first thing, if we have the portal update trigger gets triggered, then it's going to compare the portal bus length, the size of the number of portal buses, against these two values, 1 or 2. This basically just tells us how many different portals, how many different buses to send to. For this demo, I have just only set up 2 buses. So there could only be 2 portals that connect the same 2 rooms. But if I wanted to do more, I could just duplicate all this stuff and continuing adding it down, update this to 3 instead. So if this is true, so like say there's at least there's 1 portal bus, then we're going to use this trigger route to send in the audio, and we'll get all of the values from these arrays at the respective index. So if there's 1, so for the first portal bus, it'll be index 0. For the second portal bus, it'll be index 1, and so on. All of these values are then being sent to the portal DSP patch. So the portal DSP patch starts off by using this new obstruction percentage. Like I said earlier, it's the obstruction percentage from the emitter to the portal. And it's going to calculate the obstruction the exact same way as earlier, using a biquad filter and doing all this range mapping and everything to bring down the gain and filter the audio. It's then going to use the diffraction percentage against another biquad filter to help filter for the angle, the portal or the emitter to portal to player angle. And then finally, the attenuation amount is being just sent directly into the linear gain. So whatever the attenuation amount is will be what the gain is set to. And then finally, I use this audio bus writer node. The audio bus writer node just sends audio to an audio bus, and it's being sent to this particular audio bus, whichever audio bus was selected from the array of audio buses earlier. So then the last thing I want to look at is the portal source MetaSound. So this is going to be the actual sound that's on the actual MetaSound that's on every portal. It starts off with an audio bus reader. So this is like the sort of counterpart to the audio bus writer. So this takes audio from a bus, and like this bus was set earlier, right at the begin play of the portal. And we are going to use this obstruction percentage to filter it, reduce the gain if needed, and send it out of the portal position. How do we get this obstruction percentage? Well, that's got using the portal spatial emitter. The portal spatial emitter is pretty much exactly the same as the other spatial, like the normal spatial emitter, but it's just for portals. So it doesn't worry about portaling itself, and just worries about getting the direct obstruction from the portal to the player. So with that all in mind, let's listen to how this sounds. So it sounds like it's coming from the portal position here. There's filtering. There's obstruction from the portal to the listener. And there's also obstruction from the emitter to the portal. Still coming from the portal position. And the portal to original source audio fades naturally. So the last thing I want to talk about is how reverb is handled in this system. So if we take a look at the emitter here, the emitter is always sending to the reverb submix of whatever room it's in. Every room has a reverb submix. If we take a look at room 1 here, you'll see it has the large room reverb submix. This submix just has this large room reverb preset on it. There's large, medium, and small rooms reverb submixes. This is a large room, so I picked the large room one. But the question is then, what if the player is in a different room than the emitter? Well, the emitter should still be exciting the diffuse field of the room it's in, but the sound that comes through the portal should also be exciting the diffuse field of that second room, the room that the player is in. So to handle that, I just go into the portal. And then in this activate portal event, this event is called by the rooms when it's going through and checking which rooms it needs to activate. That's where this gets activated. It sends this is active variable over to its the spatial portal emitter. This just tells the portal if it needs to be looking for obstruction or not. And then it's going to check basically which room the player room is in compared to room A or B. So is the player room A or is it room B? Depending on the answer, it's going to send its own emitter. So this is the portal sound. It's going to send that 0.8 to the room that the player is not in. So the room that the emitter, that like all those emitters are originally in. And then it's going to send 0.4 to the room that the player is in. So that means that the room that the emitters are in will be using their own reverb as normal. And it'll also sound like it's exciting the second room. So let's take a look at that right now. So you'll be able to hear that this has more reverb on it when I'm in this big room versus when I'm in that small room. And when I come out here, so the sound that's coming from the portal is both going through the reverb of its own room and coming through the reverb of this big room. So that's the whole system with dynamic obstruction, audio traveling between rooms and portals, and reverb corresponding to emitter position and traveling between rooms through portals. Thanks for watching.